This video is going to help you solve the problems in the Rocking the Boat physics classroom assignment. So I have an example here of one of the problems. So the one that I have says that we have two boats anchored in the harbor and they're separated by a horizontal distance of 24 meters. So I showed here, so here's my boat and their horizontal distance between the two of them is the 24 meters. And it says the boats bob up and down as waves enter the harbor. When one boat is at its highest point, the other is at its lowest point. So that's why I drew the boat at the top of a wave and the other one at the bottom of the wave. When one boat is at its highest point, the other is at its lowest point, and there are no wave crests in between. So that's why it's one here and here, not one there and over here, or something like that. Each boat makes exactly 4 complete up and down cycles every 12 seconds, and the vertical distance between the high and the low point for the boats is 3.6 meters. Okay, and we're supposed to use this information here to determine the wavelength, frequency, amplitude, period, and speed of the wave. So first of all, and I have these in a different order here, but let's start with the wavelength because that's one of the easier ones to figure out. So the wavelength is defined as the distance from peak to peak of a wave. Well, if we know that one of the boats is at the peak and the other one is in the trough, this means that this is half of a wave, and we know the distance is 24 meters. So to get an entire wave, we would have to double that. So 24 meters times 2 is going to give us our 48 meters for our wavelength. Amplitude is another easy one to find because it tells us that the two boats are vertically 3.6 meters apart. Well, amplitude, if I were to draw an imaginary line here, amplitude is the distance from that line to the peak or from that line to the trough. So basically it would be half of the distance between the two boats. So our 3.6 meters, 3.6 meters divided by 2 this time, and that gives us our amplitude, which is going to be 1.8 meters. Okay. The next one I'm going to go to is the frequency, because frequency is defined as how often a wave occurs, and it tells us that it goes through 4 cycles every 12 seconds. So that means, so we have 4 waves every 12 seconds. That'll give us how many waves per second. So 4 divided by 12 gives us 0. And they want 2 significant figures, so 0.33 hertz. The unit for frequency is hertz. All right, next I'm going to move on to period, because period is defined as 1 over the frequency. And now that we just found the frequency, it's 1 divided by what we just found, which is 0.33. So 1 divided by 0.33 gives us 3.0 seconds as the unit. And then the last thing is finding the speed of the wave. And there actually is a little formula for the speed. So the speed of the wave is equal to the wavelength, which is this symbol here, the wavelength times the frequency. So let me just put those over here so you remember which one's which. So we're multiplying those two things together. So our 48 meter wavelength times our frequency of 0.33, and that will tell us, so 48 times 0.33, that will give us 16, actually comes out to be 15.8, but with 2 significant figures that rounds to 16, and the unit is meters per second. So these would be the values I would input into the physics classroom.